All right, we are going to move along to our next group of speakers today. Our first panel here, I'm really excited to welcome to the stage here. We have Mr. John Woods, Chief Technical Officer, as long as Gary Malouf, Head of Engineering. Welcome to the stage. They're going to have ourselves a little round table here, hosted by Fred Estante, Head of Product Marketing. So welcome all to the stage.
Thank you.
Fred, take it away.
Thank you very much, Ryan. Ladies and gentlemen, welcome. It is a pleasure to be here today. And I gotta say, I am so pumped and thrilled to share the stage with these two guys. And John, you know, I love you, but Gary's kind of like a personal hero of mine. You know, my inner Algorand lover DJ is pumping right now because I got to talk to one of my Algorand heroes right here. So John, you know I love you, but I gotta start with Gary today. Gary, everybody knows you're head of engineering at Algorand, but who really are you? I mean, can you tell us a little bit about your education and your professional path that allow you to become head of engineering at Algorand?
Are you my therapist?
Maybe, yeah, we'll see.
So yeah, I'm Gary Malouf. I've been with Algorand for the last year and a half. I've been building distributed systems for about 15 years. Originally in the ad tech space, we were one of the first teams working on real-time bidding systems when ads were going from being largely pre-purchased to on the fly. Did a stop in Forex trading for a few years, which was very enlightening. Learned ups and downs of the industry, and actually tried to take those two and combine them into a platform. Didn't ultimately work at the time. I think we're about 5 years away from that right now. Ultimately, in my last role, I was leading ML engineering, big data platforms, on-site media trading at Wayfair, and was starting to get interested in Bitcoin around 2016-ish, and ultimately met Paul and got really excited about what Algorand's up to, and here I am.
That is fantastic, thank you. What about you, John? You've been to some amazing places in the blockchain space and other places outside of the blockchain space before that. Can you tell us a little bit about your background?
Yeah, sure. I'm John Woods. I'm the CTO at the Algorand Foundation. And I've worked in 3 places involved in crypto. I worked at Consensus, where I led software architecture and applied cryptography under Joe Lubin's leadership, and we were building enterprise applications on Ethereum at that point. I also was the chief architect on Cardano for about a year, and I led architecture and applied crypto there too. So I worked at IOHK with Charles, and we were building out Cardano, and it was really interesting. And that's where I left to join the Algorand Foundation about 6 months ago. So I've been here for about 6 months. It's been a good time.
Fantastic, thank you, John. And I guess I'll start my first question with you because you've clearly been around, you know, Ethereum, Consensus, Cardano. What caught your attention about Algorand's tech? What shone to you? Like, what made you really excited about, you know, eventually becoming the CTO of the Algorand Foundation?
Sure. So I somewhat controversially said earlier, because I've seen it on Twitter, that Algorand is the first blockchain that's fit for purpose. And maybe I could dig into that a little bit and tell you why I made that statement and why I think it's true. I think a lot of blockchains out there are really excellent efforts at building distributed systems. This stuff is hard because it's the intersection of a number of different disciplines. So you can't just hire good software engineers and expect to have success. You need guys like Picard there who are like super geniuses on mathematics and cryptography. You need distributed systems engineers who understand how you can build systems that are in distributed locations and still perform well. And you need normal software engineers too. You need architects. So it really is the intersection of many different disciplines. What got me excited about Algorand was during the interview process. And so I remember thinking this is really quite funny. I was working on Ethereum, working on Cardano, working in the crypto space, you know, for 7 years at this point. And yet still, I didn't know how good Algorand was. It was only during the interview process that I kind of started digging into the tech. I think that's funny, right? I think that's why Algorand is just starting to come into the zeitgeist. It's just starting to become a popular chain, is because people aren't aware of how great this thing is. And so when I started playing with it during the interview process, making sure that I was prepared for the interviews with guys like Gary,
Sorry.
I started sending transactions. And at first I thought, oh, I must have got into a block straight away. I must have just been lucky. I must have just like, a block was minted just at the point where I sent the transaction. Then I was like, it happened again, and it happened again. And I started looking up the block time. It's like, okay, it's done. 3.5 seconds, okay. That makes sense. Then I started looking up the TPS, and that's huge as well. And then when I started looking at the structure of the code, the way it's been engineered, it's written in Golang. it was just seemingly a very well architected product. It's written in an elegant way, and I think it fits together really well. And so all these things together, the applied cryptography that Chris's team leads out, the distributed systems engineering and the software engineering that Gary's team leads out, have put us in a position where we are one of the, I think, best engineered blockchains in the space. And like I said earlier, so good that if a country or a major organization or there was some enormous uptick in transaction volume that happened immediately, the network is prepared for that. And so that you can't say that for all of the other networks that are out there. Many of them would be crushed by a high load.
Fantastic. And well, John, you just laid, the framework that building a layer 1 protocol is probably one of the hardest challenges in computer science, right? And well, Gary and the entire Algorand Inc. team, they have done it. They've built a protocol that's been up and running for, if memory serves right, 1,259 days, no stop, zero downtime. So
Zero downtime.
So how do we get there? I mean, how do you build a team? How do you build,
So first of all, zero downtime. I think Paul mentioned it in his keynote. It's really that challenge, right? It's not something we just rest on our laurels and everything's great. We're constantly working at how do you trade off security, scalability, reliability. Sometimes it's direct trade-offs between how distributed I'm going to be and decentralized versus the ability to scale up when you see bursts of transactions, right? In a Web 2 world, you can just, hey, I'm just going to go throw more servers at this and solve this problem really quickly and push a button. In a Web 3 world, you have to plan out how is data going to be sharded? How am I going to make sure that I can get a release out in a reasonable amount of time and get consensus upgraded? So the challenges are immensely more difficult, I find. Even silly things, releases, for example. In prior worlds, I push a button, my release is out there, everything's great. Oh, I got this wrong, let me push another button. In Web 3 world, it's a very different story. You're convincing people, hey, I know I just did this release last week, but we found that we can make this even better, or we think there's an area that we have to patch. And instead of being able to quick push it out yourself, you're negotiating with partners. You're going through, hey, if we go and we see this bug, how do we make sure that we fix this in a way that's secure, that people aren't going to take advantage of it before we roll it out? The security is everything as well. If you break the cryptography, it's over, right? There's no I'm going to refund you if I lose 1,000 algos. It's one directional. So the pressure's there, and the level of testing has to be immensely high. The bar for release is incredibly high, and it's real work, is what I would say.
Absolutely.
I would just build on that and just say, there may be a time when Algorand does have an issue. Code is imperfect by definition, right? And so it's not that we're immune to having issues in the mainnet, but I think the team have done a great job in building something that's robust. So it's not up and down all the time, and you can rely on it. But at some point in the future, we may end up being in an unknown situation where there's a bug that we're not aware of that does cause disruption to the network, and maybe we will suffer some downtime. But I think the testament is, when you're building systems like this, if you can engineer them where they're being attacked from all angles, because it's a high-value network and people would love to be able to break it. When it's been attacked from all angles and still it has such a high uptime where it has, I guess, at this point not had any downtime. But if you can build a system that's that robust, again, it's fit for purpose. You've built a system that can be relied upon. And so even Amazon has downtime sometime, right? But if you have production applications that are out there and you're serving customers, you want those customers to be able to rely upon it.
I would just say, add on, the bar for releases is incredibly high for us. The level of testing we go through is immense. We roll out to one network, we watch, we learn, we see how you're all interacting with it. We love when dApps interact with us on BetaNet, by the way. Please do that. We learn immensely, and hey, we didn't think of this situation. Let's make sure we cover it. And so just the level of thought that has to go into every release, and we try to hide it from you. If we're doing a good job, you're not seeing it, honestly.
Yeah.
But that's what we're trying to do, is hide it. It's incredibly hard. The most reliable thing I would say is our consensus protocol has been consistent from day one, and that takes a whole lot of pressure off of us. But it's an incredibly high bar.
Fantastic. And you touched on a really good point about testing of the code, right? Given that it's so hard to roll back anything doing a distributed system. Can you just expand a little bit more on the testing framework that we have, what you do on the code front, but also private net, beta net, this and that, mainnet?
So there's two aspects, right? There's the functional testing of, do I have this right, which is its own high bar, and you have You have several levels of automated testing there. You also have the manual, like, hey, go get 10 apps to go use this code, is the bar. Immense levels of code reviews. We have several senior people that are looking at every commit before it ever makes it to the main branch to go out. And then you think about performance testing, which is a major topic, obviously, in blockchain world. We've built several scenarios. I think we're up to 4 or 5 that we run today before every release. We are running them constantly because we have a heterogeneous network. Different people have different specs on their relays versus participating versus non-participating nodes. You have to anticipate, every one relay I have, I might have 500 connections to it. And how does that play out? And then this relay, which doesn't perform quite as well, might get half of those. And so if you try to do everything homogeneously when you're testing, it doesn't work. So that's why we run actually several different scenarios, very large numbers versus very small numbers of nodes. Clustered in certain regions is another thing that we're looking at really hard. That, I think, is probably one of the biggest challenges. And then you have to go and put it on the main network, and you find out, hey, I got these 5 assumptions right and these 2 wrong. So how do I learn and adjust and build more scenarios, or this one, discount these 2 that don't make any sense? It's a constant state of learning, which makes it a really fun challenge to go after.
Cool. And I got a question that I've been dying to ask for a very long time, so I might as well do it here. Do you guys over at Algorand have any sort of ops room, like a place? It doesn't have to be physical, it can be online, but where we have all these dashboards monitoring the health in a much deeper level that we've seen in just the plain explorers in the system, that are monitoring all these crazy stats about the network, making sure everything's fine in beta net all the way to mainnet. Do you guys have something like that? Can you speak to that, or if you cannot speak to that,
we
fine.
We have a great amount of telemetry particularly on relay nodes. People choose to opt in when they want to support the protocol. It's definitely an opt-in process. But it allows us to see when different relays are performing at different scales. We have that available in real time. We of course have the actual main network stats, how many transactions in a given round, latencies, and if they're tweaking between rounds at times. We look heavily at how many different dApps are interacting throughout the day. So yes, we have a bunch of dashboards up in the back room. I can't say we don't have to watch them 24/7. We have plenty of automated alerts, which is beautiful. And first of all, if the network's even having a hiccup, you hear of it. We have a great community. It's a large, engaged community. You hear if there's even a hiccup. So daily basis, we're aware of anything that's going on. So yes, we're pretty dope.
Fantastic, awesome to know. John, any further questions, or can I?
No, I think it's great. I mean, I have experience. I'm not building the protocol now. I'm at the foundation, obviously running the show, keeping an eye on Gary. But from my days in Cardano, where I was building the protocol, and I did have to sign off on the release. It's high pressure, right? Because it's people's money. I don't want to be the guy who signs off a release and then there's some massive break in the code, and then people end up in a lot of pain. And so we had the same testing process there when I was working there, and it really is quite heavy. And sometimes releases would be code complete for months before we actually get them through the performance engineering testing. Again, when you're building distributed systems, a big component after the security, after you've got the engineering done correctly to a spec, there's a big part of it, which is how does it perform? How will it perform in the real world? So you can have simulation, you can have benchmarks, you can even deploy in the real world and see how it performs. But that piece about regressions in performance is probably something that's very tricky to manage when you're building out layer ones, right? Because you can add new features, and all of a sudden you find that the smart contracts take a certain number of microseconds more to validate, and all of a sudden it's affecting your block propagation times, and now it's affecting your consensus. And so it really is a tricky one to get right. And so I'm so glad I don't have to deal with it anymore.
Thanks. One other piece I'll add to that, the other challenge that's unique to blockchain is that when I push a button in release, it doesn't mean everybody gets the feature instantly, right? You also need 90% of the online stake in an Algorand to adopt it. And sometimes you're convincing people that they need to upgrade now, right? And this is a decentralized world, so I can choose not to upgrade. And actually, our protocol, we have a pretty high bar before we add new features. And it's not even our bar, it's just the nature of the consensus protocol, 90%. And it can take days to reach that because not because anything's wrong, the code can be fantastic, it's a great feature, it's because it's a decentralized system and you need people to choose to adopt it. And I think that's a very important aspect that we try to make people aware of.
Another one that I have a problem with is people go to the GitHub repo, right? They git clone the code and then they compile the node based on the main branch. And they're running that, so they're ahead of everyone else, and it can be a pain in the ass.
We see that with the indexer quite a bit too.
Right. Yeah. So yeah, I agree. Trying to keep people on track, tricky.
Fantastic. All right, John, well, I guess the next one is to you because you've built either protocol or interesting dApps, Consensus, Ethereum, then Cardano, and now Algorand. Can we do a little dive there on what is the difference, like what you see both from the technology stack, looking back at like the core protocol and also developer experience throughout these three major blockchains they worked on, and how do you think Algorand bodes, moving forward in the future?
Yeah, sure. So to contrast the development experience with Cardano, I think Cardano's engineering, its consensus protocol is called Ouroboros, and it's a longest chain wins type consensus protocol, but it's heavily coupled with data propagation. So with Cardano, if blocks don't reach the network within 5 seconds, you start to have short forks in the Ouroboros consensus algorithm, and it will slowly dissolve to the point where consensus is lost. And so development there was very much focused on systems engineering, just like making sure the performance was good. And it was also written in Haskell, which is an insane language to use at any time for any reason. So in contrast, Algorand, although I'm not developing the protocol directly, is written in Golang. Obviously, not my favorite language in the whole world, but a reasonable choice. I think as well, doesn't have as many gotchas. Scaling out Algorand I'm not saying it's easy, but it's easier than scaling out some other chains because of the way it's been architected. And so you can see that with the gargantuan leaps that, Gary's team have made over the last year. Transactions per second up, 5, 6x. Finality down by 20%. These are huge leaps. These are gargantuan leaps. And so you're only able to do that if your underlying engineering is strong and if you've built things the right way from the ground up.
It's nice to have the language not fighting you, is what I was also saying.
Yeah,
Right.
exactly.
When we're thinking about how do we deal with performance, it's not, we're not thinking about, how do I work around this language, which is focused on static. I know which one you're talking about. I worked in Scala for a decade based off Haskell.
But even like the compiler for Haskell is called GHC. And so there's different versions of GHC. And there was times when the compiler was putting in, in the actual machine code, we would find that the instructions it had chosen to use were outrageous. You would hash include a file or change a dependency slightly, and it would totally change how the compiler would produce the bytecode. And it's just it's like there's a ghost in the machine fighting us, And so I think having a choice like Go makes things easier.
It also helps that a lot of the cryptographic functions are much easier to work with as well.
Yeah. Exactly.
Yeah, fantastic. But John, you just mentioned machine code, so maybe it's a good point to change gears a little bit and ask, Gary, why has Algorand decided to create its own virtual machine, the AVM, instead of just taking the EVM and plugging into PPOS?
So if we go back 4 years when we're building the Algorand blockchain, we knew we needed to be able to iterate quickly when we launched, and we needed to be able to have something that fit with how our protocol works. So it's going to have the performance and scale that we need. Trying to retrofit the EVM just wasn't going to happen. It's not the most performant system in the world. I know people enjoy writing Solidity, so no taking shots there. But from a performance perspective, from ability to maintain it, we thought it would be a nightmare. I think that I don't regret that decision that Algorand made. I was not here at the time. It was the right one. And we've ended up supporting layer 2 solutions that get you Solidity over. John's worked with some of them most recently. But in short, the AVM is built for us. It performs very well. It allows us to hit the high TPS we want to be able to hit both now and in the future. And we'll be able to continue to maintain and iterate on it. The EVM was not going to be able to do that.
Fantastic. And for those people that may not be as much aware of the differences, can you just say that the basic differences between the Algorand virtual machine and the Ethereum virtual machine?
It's more of the instructions that each is able to run and how it fits against Algorand. So I think it would be going level too deep into the details to go there, but I would say the EVM does not have Algorand as a target in mind.
Yeah, I would say for the non-techies, the AVM is just way better. But jokes aside, it's built for speed and precision. It is easily my favorite VM. I mean, look at the other VMs that are out there. There's the Java virtual machine, and that sucks. I think we can all agree on that. The Ethereum virtual machine, clearly not as good. So I think the team have done a good job with the AVM. And if you look at some of the things that are coming out now, we have really quite mature instructions. So there's an opcode, there's a low-level instruction you can ask the AVM to perform in one step. that will verify elliptic curve signatures on Edwards 25519. Similarly, there are other kind of pretty cool, I think, constructions around the opcodes that make it, I guess, quite efficient when the compiler is writing the bytecode. So I think they've done a good job with Teal. Earlier on, I was talking about AlgoKit, and really what I'm trying to do there is work with my colleagues at the Inc. in order to bring a developer experience that is simple and fun. And so I think you can have the AVM can be great, and technically it can be wonderful, and the opcodes can all be well formed, and we can have it be performant, and that's all great. But just like people don't write really a lot of stuff in ARM assembly or in x86 assembly or in MIPS assembly, we don't want people to have to be down at that level. And building these abstractions happens over time as platforms mature, of course. People used to write code, on punch cards. Then they wrote it in assembly. Now we have nice high-level languages like Rust, and it's easier. And so this is the journey that the development experience for Algorand is going on. And it's maturing at a very fast rate. And I think when you see AlgoKit drop in Q1 next year, you're going to think, hey, this is an experience that I'm comfortable with, that I'm familiar with. And we should see, again, a surge in adoption.
Cool, awesome. All right, Gary, recently you taught me a new word that I had never heard before.
Thank you. Thank you.
All right, when we were discussing protocol, you mentioned about just going back to nodes for a little bit, right? You talked about the polymorphic nature of nodes, and I had to look that up because I had no idea what that meant. But and the explanation you gave to me was nice, so maybe I think people would also appreciate, just understanding, like for the Algorand protocol, why did we decide to go the route that we have, the construct that we have for the different types of nodes?
You want install to be as easy as possible, so you want John to be able to spin up a node as fast as I can, really quickly, and for completely different use cases. So we have one install process with slightly different configurations based on what you're trying to do. So if you're a DApp runner, you probably want a non-archival, non-participating node, and it's basically you tweak 2 settings, go. If I'm running a relay, the foundation's sponsoring me, and I'm running a relay, I want to be able to tweak 1 setting, push a button, and I've got my full archival, full relay node. And the whole idea with that is it's one code base. The only difference is configuration. It keeps it simple. It's easier for us to test and maintain over time. It allows us to experiment with different combinations of settings to figure out what's optimal for different situations. We have something like 7 or 8 different user stories of user types, that I would call it. Each of them run in slightly different configurations, and being able to quickly support all of them is why we call it a polymorphic. It's polymorphic because you're only changing the configuration, essentially, right? It's one install for multiple types.
Got it. And then moving forward, do you think you're gonna stick to that construct? You're gonna add more
Yes,
options, reduce options?
It makes a ton of sense. We will try to streamline the options to make it easier to identify what I should be running. I think we have great instructions on our dev portal right now, but we will streamline it even more so it's basically interactive. I want X, Y, and Z. Okay, this is what I need.
Cool. All right. I don't, John, do you have a follow-up to that, or?
No, I think that's very well answered.
All right, cool. Awesome. We only have, sorry, you're going to say something?
No.
All right. We only have maybe 5 minutes left, but so maybe you can shift gears to the conversation, like looking forward to the future. What can you say about the areas of interest, areas of research that Algorand Inc. is pursuing? John started the conversation before. It takes a really multidisciplinary team to, research, code, build, test a layer 1 protocol. So, what are you guys focusing more resources in terms of research and development for the future?
So you heard some hints of this in the last talk with Chris in terms of building snark proofs, and that will be an effort in the early part of 2023. The sub 3 second rounds is a huge goal for us, and it sounds really simple, and it does. It's like, hey, just turn down the round latency. No, you actually have to change pretty much everything from how the network communicates with one another to how the CPU performance of the nodes in order to squeeze every bit of performance out of that. That will take a huge amount of effort, experimentation. We have like I mentioned, those suites and suites of performance tests. Those are going to only get added to, and it'll be an intense effort over the next 6 to 12 there. The indexer is actually our indexer, many of you rely on for one case or another, is actually getting split out into multiple components so that it can scale with the rest of the chain as we go up to thousands of TPS transactions per second. That'll be a major one. And of course, everything we can do to support AlgoKit's success, whether at the PyTeal level or similar, that is a huge priority for us.
Thank you. AlgoKit is our focus.
Yeah. Fantastic. All right. So basically, what you're saying is that maybe sometime within the next few months, we might have another performance upgrade to reach that sub 3-second block finality.
You will see several more releases on the way there. I don't think you'll see one release that drops it almost a second. I think you'll probably see several where we give you a bonus. Hey, with this consensus upgrade, we just cut another 200 milliseconds off. You'll see it gradually get down there. Like we did a 500 millisecond cut in one release earlier in the fall, and you'll see several more over the next few months.
Fantastic. And the objective is around 2.5 maybe?
I'm going to say sub 3.
Sub 3. Cool.
But it's already so fast. I mean, like, it's like sending a text message, right? Like, I was showing my mom. I was like, hey, mom, download Parawallet, whatever, buy some algo, trying to pump it, you know. And she was sending it back and forth between my phone and her phone, and I was like, look, it's like sending a WhatsApp text message or whatever. It's like, it's really fast. It's good. It's about the same time you wait when you're in a store and you tap a Visa card, right? Like, it's at a good place right now. And so yes, it'd be great if it's even faster, but I think it's very, very good UX right now.
Using applications built on top of us, I can say it is in a lot of ways, it's a lot more streamlined than the experience I've had in Web 2 applications. But the latency, at one point I thought it might be a concern, it's a non-issue today.
Yeah.
Right? We want to optimize. I think we want to get down so that there's folks that can really benefit from the really tight round times, and that's why we're going to do it. But from hey, we're final in 3.5 seconds. It's pretty amazing.
Yeah, it's pretty amazing. Can confirm.
Fantastic. All right, I think we only have maybe 2 minutes left, so I do have one last question for John, but actually I just want to see if anybody from the audience has, all right, quick hand up. Didn't even let me finish the sentence.
No hard questions, no controversial questions.
Any questions for these guys?
On the panel, you mentioned that if there's an attack with transactions per second, that Algorand is capable of still functioning, unlike a lot of other blockchains. Can you please go into that a little bit further? What's the protocols? What's the fail-safes that you were talking about?
Say that one more time because it's hard to hear you just because of the echo.
Sorry. Earlier on the panel, you said that if there's going to be like a transactions per second attack, like a large amount of transactions per second, you guys are going to have a fail-safe to make sure that the blockchain still works.
Okay.
If I understood, I believe that was said earlier.
Maybe you said that, did you? Fail-safe on transactions?
I think that was you, actually.
Yeah.
Yes.
You said that that unlike other blockchains, that Algorand would keep working, that there's a protocol in place or a fail-safe. I might be misquoting, but something like that.
Yeah, it's okay. So yeah, I think what maybe you're speaking about is when I was saying we had no downtime whatsoever. Is that what you're talking about? And then I was saying sometimes we might hit a problem.
Yes, sir.
Oh, sure. So yeah, what I'm saying there is I just want to set people's expectations because this stuff is really hard. And even like emergency systems go down in countries, right? Like people have issues with like the space stations, you know, like there's issues out there. And so I think when I was at Cardano and when I've been working even with Algorand, I try to stay away from like hyperbolic statements about the network. So like you see a lot of protocols and they say, oh, we've got 60,000 transactions a second. Yeah, but we're like, you know, up and down like a yo-yo and like half of them are for consensus. Or you see other platforms and they're like, oh, you know, we're so cheap and we're so decentralized. Yeah, but not really because like you're actually running 80% of your nodes on AWS East Coast. So like, I guess what I'm just trying to say is, yeah, it's great we've had no downtime, but for the community, I try to discourage a little bit that kind of like showboating, you know, stats and metrics about that kind of thing because it may be the case. At some point in the future, there's an unknown bug. Maybe it's in the CPU, maybe it's in Windows or Mac OS, maybe it's in Linux, maybe it's in the software itself. But it's not impossible, of course, for the network to have issues. And I guess my core point was building a network that you know is strong and you're doing your best in terms of all the testing, in terms of being responsible with how we develop, so not just rolling out features just to be first. These things are important. And so even if we do end up having an incident at some point in the future, it's something that we can recover from, and it's something that won't happen very often because of the level of effort that's been put in to make this thing robust.
I'll just add, too, we're looking at the incidents that have happened over the past year with other chains without going into any specifics. And
yeah, so did you say Solana, Gary?
I didn't. I'm sorry, I couldn't hear you clearly.
I think you said Solana.
We're looking at, basically what I'm saying is we're learning from those incidents, too, and actually recreating those scenarios whenever possible to make sure that that's not going to, we don't want to see a reoccurrence.
Yeah, I mean, put it this way: you're not going to see Algorand, right? Like being rebooted from a Reddit thread while the lads are on Telegram, you know. So you're not going to see that.
Yeah.
Thank you.
Thank you so much.
We appreciate the questions. Let's give a round of applause here to our panel. Fred, thank you so much for organizing this. Gary, thank you so much.